What's good, everybody? AP Media 83 here. Hope everybody's doing all right today. What's going on, D. Scott? Brian Will. How you brothers doing today? And as the title suggests today, we're going to be talking about the dialysis machine. The dialysis machine. For those of you who don't know, I'm a dialysis patient. Been one for 4 years. So yeah, I was diagnosed with kidney failure, and now a dialysis patient. So right now I'm trying to get a kidney transplant, and that's a process in itself. But today I'm going to talk to you about how the dialysis machine works. What's good, Aquateki baby? It's good, Aquateki. Good to see you. So, give me just a minute. I have to pull this video up. Just give me just a second. Should have had this video queued, but hey. Let's see here. All right, got that queued up. Now I just need to share my screen. And for those of you just coming in, I'm going to be talking about the dialysis machine today. Nah, I'm actual dialysis patient. Let's see. Here we go. All right, you should be able to hear this.
Hi, welcome to another Biomedical Engineers TV video. In this video, we will look into dialysis machines. Let's start the video from the beginning of the dialysis machine. The history of dialysis dates back to the 1940s. The first type of dialyzer, then called the artificial kidney, was built in 1943 by Dutch physician Willem Kolff. Kolff,
For the record, I didn't know this information either until I looked it up.
Had first gotten the idea of developing a machine to clean the blood after watching a patient suffer from kidney failure. When his invention was completed, he attempted to treat over a dozen patients with acute kidney failure over the next 2 years. Although only one treatment turned out successful, he continued to experiment in improving his design. Kolff came to the United States in the late 1940s and went to work at Mount Sinai Hospital, trying to get kidney treatment to become a health service. Because of the hospital's opposition to the type of therapy at the time, he and his colleagues conducted treatment issues at a separate site. More experimentation led to the manufacturing of an improved design in the early 1950s. However, Kolff's device only treated acute kidney failure and not end-stage renal disease, or ESRD. How the dialysis machine works. The dialysis machine draws up and warms purified water to physiological temperatures. The heated water then undergoes desertion under vacuum to prevent dissolved air from coming out of solution as negative pressure is applied during dialysis. Air bubbles in the dialysate cause the blood leak detector and the conductivity detector to malfunction. They also lock part of the dialysate pathway, increasing channeling and masking parts of the membrane surface area. The heated and deaerated product water is then mixed with the concentrate to produce dialysate. To ensure proper proportioning, the conductivity monitor downstream from the proportioning pump continuously measures the electrical conductivity of the product solution. Because malproportioned dialysate may cause severe electrolyte disturbances in the patient, leading to death, The conductivity monitor has a narrow range of tolerance and is usually redundant. Dialysate conductivity.
Yeah, just for reference, you have to understand when you're on the dialysis machine, it literally it's literally regulating your blood pressure as well. So sometimes they don't want your blood pressure too high because you can have a stroke. But if your blood pressure gets too low, you'll get sick and want to throw up and get dizzy and might pass out. This is a very complex. It's very complex. Let's continue the video.
May be altered by temperature, the presence of air bubbles, or malfunction of the sensor, usually an electrode. Periodically, the conductivity monitor must be calibrated using standardized solutions or by laboratory measurements of electrolytes in the dialysate. Let's learn about the components of dialysis machines. Single-patient hemodialysis systems can be divided into three major components: the dialysate delivery system, the extracorporeal blood delivery circuit, and the dialyzer. Each system has its own monitoring and control circuits. The delivery system prepares dialysate, a solution of purified water with an electrolyte composition similar to that of blood, and delivers it to the dialyzer. The external blood delivery system, extracorporeal blood circuit, creates a portion of the patient's blood through the dialyzer and returns it to the patient. The dialyzer is a disposable component in which solute exchange or clearance takes place. The temperature monitor within the dialysate circuit sets off an alarm if the dialysate temperature is outside the limits of 36 to 42 degrees Celsius, and dialysate is pumped directly to the drain, automatically bypassing the dialyzer. Located downstream from the dialyzer, the dialysate pump controls dialysate flow and generates negative dialysate pressure. The dialysate circuit must be able to generate both.
For feature for further reference, basically what this is doing is cleaning your blood. Is what you but and that's what your kidneys actually do when you're not on dialysis. It cleans your blood from toxins and all kind of nasty bacteria and stuff. And basically that's what this machine is doing for you because your kidneys aren't good.
Negative and positive dialysate pressures within the dialyzer because, although many dialyzers require a negative dialysate pressure for filtration, dialyzers with high KUF or conditions that increase pressure in the blood compartment require a positive dialysate pressure to limit filtration. The dialysate circuitry controls the pressure by variably constricting the dialysate outflow tubing while maintaining a constant flow rate. The dialysate delivery system also monitors the filtration rate, either indirectly by controlling the TMP, pressure controlled
Yep, I see this kind of machine every single day.
ultrafiltration, or directly by controlling the actual filtration, volume controlled ultrafiltration. Earlier dialysate delivery systems used pressure controlled filtration, requiring dialysis personnel to calculate the TMP, enter the TMP into the machine, closely monitor the filtration rate, and recalculate and adjust the TMP as needed. To prevent excessive fluid removal, when using dialyzers with KUF greater than 6 milliliters per H per mmHg, to prevent excessive fluid removal.
Let me talk about that for a minute. When we're talking about excessive fluid removal, oh boy, there's a difference between normal cramp you may get at night and a dialysis cramp. See, with a normal cramp, your blood is flowing properly, and the cramp eventually goes down. With a dialysis cramp, your blood is still being circulated in the machine, so that sucker hurts like a mother. There's a strong difference between a normal cramp and dialysis cramp, and it hurts. It hurts. Let's continue.
Removal when using dialyzers with KUF greater than 6 milliliters, dialysate delivery systems capable of performing volume-controlled filtration are mandatory. Such systems have built-in balance chambers and servo mechanisms that accurately control the volume of fluid removed during dialysis once the desired goal is set. Let's learn about types of dialysis machines. First is the conventional dialysis machine, which are used in hospitals or dialysis centers in a conventional standard process.
Yeah, this is the machine I'm on. is I go to a dialysis center to get this process done. But there are other types of dialysis processes too. Let's continue.
These machines are heavy, bulky, and not a cost-effective equipment. They also require standalone, separate RO systems for assisting the machine.
Yeah, basically, the dialysis machine has its own operating system and stuff, and you can see it right here.
Second is the portable dialysis machine. This type of machine can be used at home or small clinics. A company called NX Stage
My father had a machine like this. It's actually gotten smaller since then because that machine was huge. It used to be huge. You have to they had this bag of liquid that would pump into my father, and I would have to empty the liquid that came out of it, which is basically all the toxins and stuff.
System 1 is the first and only truly portable hemodialysis system cleared for home use in the United States, including solo hemodialysis during waking hours and nocturnal hemodialysis while both the patient and care partner sleep. It was specifically designed for patients to use in their homes
Oh yeah, before I continue, hit the cash app, support the show. This is not information you're going to get anywhere else.
and is small enough to allow patients to travel and bring their treatment supplies with them. And the third type of dialysis machine is the Vicenza wearable artificial kidney for peritoneal dialysis developed by AWAC Technologies is a miniaturized system for continuous flow PD with capacity to regenerate spent dialysate. Its weight is just about 2 pounds or 1 kilogram. It's small in size and battery operated to provide effective recirculation of PD solution at a rate of 20 milliliters per minute for more than 12 hours. The system is meant to be an alternative for continuous ambulatory peritoneal dialysis or CAPD and automated peritoneal dialysis or APD to reduce the time consumption, the steps of procedure, and amount of solution required to perform PD. The system is based on a combination of a long overnight dwell exchange and a continuous flow PD during the day, performed with a special catheter and a special mini cycler which utilized a mixture of sorbents to regenerate the PD solution. There is another type of dialysis machine which is also known as CRRT machine. Continuous renal replacement therapy is a special type of dialysis that we do for unstable patients in the ICU whose bodies cannot tolerate regular dialysis. It is a very different type of dialysis from the routine type that patients may be familiar with, and it requires special skills and expertise. Regular hemodialysis is meant to be mostly an outpatient procedure. It is done usually 3 times a week for 3 to 4 hours at a time. The flow rates used to clear waste products and remove fluid from the patient are very fast, potentially putting stress on a patient's heart and blood pressure. If a patient already has a low or unstable blood pressure or has heart issues, he or she will not tolerate regular dialysis. CRRT is a slower type of dialysis.
Yeah, my cousin had that problem. His blood pressure. He's passed away since then, but his blood pressure kept low, and I can and having had that myself, I can imagine what kind of pain he was in.
That puts less stress on the heart instead of doing it over 4 hours. CRRT is done 24 hours a day to slowly and continuously clean out waste products and fluid from the patient. It requires special anticoagulation to keep the dialysis circuit from clotting. This was the simplified video on dialysis machines. We hope you liked this video, and if you did like it, hit that like button and subscribe to the channel. We'll see you guys in the next video.
All right. Yeah, that's the dialysis machine. It's it can be complicated. There's a lot that goes into it. Now, well, first let me get this banner off. Now let me show you some stuff. Oops, give me a second. Come on, OBS, get it together. There we go. All right, now let me show you some. Let me show you something. See this right here? That's where they connect me in the machine at, in my arm. I would take this off to show you how much scarring tissue I have, but it might start bleeding again. The other way for them to do it is to actually put it in your chest. I don't know if y'all can see that, but they actually put it in your chest area, and they don't put you to sleep for it. They don't put you to sleep for it. They pretty much give you some numbing medication and hope for the best. So yeah, that hurt like a motherfucker. Let me just put it that way. And I personally dialyzed for about 4 hours every 3 days, and every 3 days I get two 15 and a quarter needles for all. So to all of y'all that are afraid of needles, I get two 15 and a quarter needles every 3 days. I have to look at that every 3 days. And once I'm done with dialysis, I have to hold where those needles are at so I don't bleed out. You have to hold each needle hole for at least. I do it for 7 minutes, so it doesn't. So you don't start bleeding everywhere. Yeah, this is for those of you who don't know, dialysis is no joke. There's a lot that goes into it. Now, technically, the catheter is easier, but the catch is it can get infected easily. I know because mine's got infected. I kept getting a fever after treatment. Techs couldn't figure out what it was. Nurse couldn't figure out what it was. I went home. I went to go take one of my pills, and I literally threw it back up like I had food poisoning. So after that, I was in the hospital, and quite frankly, they couldn't figure out what it was either. And I was in there for over a week. And eventually, they finally tested the blood in my catheter, which links, if you don't know, links directly to your heart. And they told me I had a nasty bug in there. And they also told me if I hadn't gone to the hospital, I may have died from that nasty bug. So yeah, dialysis is no joke, folks. After treatment, I'm surprised. If you can't hear it in my voice, I'm tired as hell. I'm probably gonna take a nap after this after I get done with this live stream. But after treatment, dialysis is like having is like having a full time job, pretty much. After treatment, you're worn out. You don't want to hear anybody's crap. I might go home. Make some lunch slash dinner slash breakfast, depending. One day I don't always eat breakfast before I go to dialysis, and sometimes I stay up and watch YouTube. Don't have cable, so I don't watch it. So I don't do cable. Sometimes I go play a video game, and sometimes I just crack. I just crash and go to sleep, and wake up later and do whatever I need to do. But yeah, this is the process, folks. It's been doing it for 4 years, and do I get burnout? Of course. Yeah, yeah. You get burned out. It's easy to get burned out. Uh, but I have to go. It's a process I have to go through. It's not. Do I dread going to dialysis some days? Of course, but I get my ass up and do it anyway. It is what it is, and I do what I got to do. But yeah. Now, let's see what I'm gonna do now. Well, right now I'm gonna have a little fun right now. Let's see here. Default exe. Let's shrink my video back down. Now let's have a little fun. We're going to open Blender. For those, if those of you just coming in, you missed the video. Just rewind. Just rewind, and you be watch it on the playback. I go over what the dialysis machine is and what it does. Yes, Psychotech, staying alive is a very powerful motivator. All right, let's see. I think Blender's ready. Give me a second. Make sure I'm targeting Blender. Default exe. Uh-oh. Here we go. Let's see. Blender. Technology, folks. Sometimes it don't want to act. Sometimes it don't want to act right. Turn my camera on. What's up, folks? And all right. Huh. Linda don't want to act right today. Let's see here. Uh, oh, wait a minute. Okay. Let's see what's going on here. Close out of that. There we go. All right. Now let's well let me give you an idea what I know what I want to draw with this 3D plane. Let's see, we'll go to Blender, and we're going to get a let's see, mesh. Oh, got some new options actually. Interesting. Um, let's do the scan mesh. We're gonna get a simple plane. We're gonna spread this plane out, and let's see here. We're going to get. Where's that? Here we go. Going to create a cube right here. Bring it up. And we're gonna make actually just gonna make that a cylinder. Yeah. Kind of set my scene up here. This is kind of what the this is kind of a 3D representation of what the machine looks like. Give me a second. I'm gonna turn on EV. Nothing real special here. Just kind of give you a 3D perspective of what it looks like when you go into dialysis. All right. That's a good angle. We're going to go into edit mode, and we're going to give this a material. Let's see, new material. Okay, now Blender wants to be slow. Give me a second, folks. Here we go, material. Make that red. And that's usually the trash can. We're gonna kind of play with this a little bit. Trash can. The machine is usually set up on my right side because it's in my right arm. So the machine's usually set up on the right side of me. Then we're gonna let this cube represent the machine. And this is a hazardous trash can. This is where they put all your tubes and stuff with all your blood in it, with all your leftover blood. That's also where they put the needles and stuff. Like I said, this is a very complex thing. Yeah. Thanks, Aquatechie, and what's up, Anthony? For those of you just come in, hit the like button if you like the content you see, and hit the cash app. All right. Let's play some more with this. Uh, the machine. And go ahead, cube. Not perfect, but this is usually where the computer screen's at. And we're going to select this, move it over just a little bit. This is some butchered mauling, but you get the idea. Yeah, that's usually where your computer screen is, and there's a bunch of buttons and stuff. And all let's see, I'm gonna do this. Oh, snap. Let's see, back. And all the tubes and stuff usually goes, let's get a cylinder for that. Let's get a cylinder for that. Uh, uh, let's see, let's get a cylinder. All the tubes and stuff is usually located right here. Okay, right there. It's not exactly there, but you get the idea. Let us move that up just a little bit. And we're going to move that back in just a little bit. Move that back. Actually, we're going to move that to the other side. Now, let's see. What am I going to do here? I'm going to pull out a model plane. Uh, Shrink it down just a little bit. We're going to edit this. You'll see what I'm doing in a minute. Edit this. We're going to go to edge mode. Uh-oh. Oh, that's right. Model plane. Shoot that out. Go back to face mode. And this is usually where the chair is at. The chair is usually on the side of the machine. And this is where I sit at, usually. Uh, you know what? I'm just going to make another cube. Give you an idea. And this is just kind of some rough draft modeling. I might actually do actually model this for real in another tutorial. I don't know. I'm gonna leave it right there. Leave it right there. It's usually a recliner seat, so I can put my feet out. You often need to do that so you don't cramp. But well, let's make a. Uh, Actually, we're gonna squish that just a little bit. All right. For those of you just coming in, hit the like button, share, subscribe. Want to support the channel? Hit the Cash App. All right. All right. With this object and put that mode. Extrude that out. So we are going to add a new material. And we're going to make that, well, we're going to go to edit mode. And we're going to make this a pages color. Y'all get the idea. And this is what it kind of looks like when I walk into dialysis. There's a chair, there's a machine, there's usually a tech to get on my nerves and to stick you. And then there's a bunch of nurses that check your breathing, they check your lungs, they actually check your heartbeat, make sure everything's working fine. Because if you have too much fluid on you, it can get in your lungs and it make it very hard to breathe. I've never tried it, and they won't let us plug anything up. To answer your question, Aquatech. Uh, but yeah, this is the setup I usually see when I go to dialysis. This is the setup I see. It's not always fun. I always carry a tablet with me and try to get through it. Well, that's all I got for this stream. I'd like to thank y'all who came through and watched me explain this. Hope y'all have a good day, a blessed day, and let's see. Just pulling my brand stuff up. This is AB Media 83, and I'm out. Peace. Yo, this is AB Media 83. Want to support the channel? Hit the Cash App. Also, be sure to like, share, and subscribe to the video. Also, be sure to hit that bell notification so you can be notified the next time I upload a live stream or video. And always remember, keep it grinding, keep it pushing, keep it moving. This is AB Media 83, and I'm out. Peace.